Hi there. Today we will talk about quadrilaterals inscribed in a circle. To understand this, let's get started with understanding the word inscribed. The word inscribed means enclosed by inside another geometric shape. What does that mean? That means if, let's say, we have a shape, right? And if there is another shape, just like this. For the simplicity's sake, we are just taking it like this. Then the inside shape, if we color it, let's take it blue and let's highlight this. The inside shape. This shape is inside another geometric shape. This whole scenario is called inscribed. Inscribed means surrounded by something, enclosed into something. So when we are talking about the inscribed polygon, that a polygon, like a polygon, that means a straight line figure that is enclosed. When a polygon is with its every vertex are on the given circle, then that is called inscribed polygon. The one that I drew right here and the another is right here. Inscribed polygon. So you can see it is a pentagon here, and all the vertices, they are touching the circle. So it is circumscribed circle. The circle is circumscribing it and the polygon is inscribed. In means inside. Circum means outside. So when we are talking about the circumference also, circum means fencing or outside, right? So that is the term circumscribed. That means the circle is outside. In, that means inside, right? So this is, I hope this is clear. So if this is clear, let's understand another term which we often talk about in these type of questions is cyclic quadrilaterals. A quadrilateral that can be inscribed in a circle is known as cyclic quadrilaterals. Because a quadrilateral is inscribed in a circle, we talk about a theorem about it. And that theorem says that if there is a quadrilateral inscribed means again inside a circle, touching its vertex on the circle, then it can be possible only if the opposite angles of the quadrilateral are supplementary. That means add up to 180 degrees. I have seen this type of question many times in various competitive exams and various standard-based grading and the state standard exams that students have to take. So, and it is a common misconception that students, they consider, okay, angle D and angle F, they are congruent. But we are not talking about the congruency here. We are saying angle D plus angle F should be equal to 180 degree. And in the same way, angle E plus angle G should be equal to 180 degree. Based on these, let's try a few examples. I will solve a few questions for you and then you will solve one question for me. Okay. This one is for you to try. Let's get started with question number 1. So we have just learned that if a quadrilateral is inscribed in a circle, let's first check whether it is totally inscribed or not. How we can check? If the vertex is right there on the circle. And check. Yes, it is inscribed in a circle. So if a quadrilateral is inscribed in a circle, that can happen only if the opposite angles are supplementary. That means we are talking about these two angles and these two angles. So you can make a cross and identify those. So we can say x degrees plus 90 degrees should be equal to 180 degree. Solving it using a one-step equation, and we can say x degree is nothing but 90 degrees. One thing is done. check. Let's find out what is y degrees. The same thing. Y degrees plus 100 degrees should be equal to 180 degrees. That being said, using the one-step equation, that will be equal to 80 degrees. Happy chappy answer is right there. I solved one question for you. You try on your own. The second question. Let me go to the third question that we have. Now, in this question number 3, we have a variables in play here. But let's check whether it is inscribed or not. So let's see whether all the vertex are there on the circle. Yes, they are there. So check. Yes, it is inscribed. Quadrilateral is inscribed. Because a quadrilateral is inscribed in a circle, that means opposite angles will add up to, yes, you are right. They will add up to 180 degree. So let's start writing the equation. I can say 4x plus 1 plus 8x minus 1 should be equal to 180 degrees. If I solve it further, I can say 4x plus 8x is 12x, and plus 1 and minus 1, that will cancel off, and 180 degree. Using one-step equation again, dividing 12 both sides, I will get x is equal to 15 degrees. Okay, let's not put degree here, just x is 15. When x is 15, can I identify these two angles? Let's plug it here. So 4 times 15 plus 1. What is 4 times 15? 4 times 15 is 60. 60 plus 1, 61 degrees. This angle is 61 degrees. Let's figure out what is this angle, the top one. We'll do the same drill again. 5 times 15 minus 4. What is 5 times 15? 5 times 15 is 75. 75 minus 4 is 71 degrees. One more check. Well, let's find out these two bottom angles. So I know 4x plus 1 and 8x minus 1, they should add up to 180. Let's plug it right there, the value of x. So 8 times 15 minus 1. So 8 times 15, it would be 120 minus 190 degrees. One more time. I need to find the value of y. I know 5x minus 4, I just got 71 degrees. So 71 degrees plus angle y degree should be equal to 180 degree. Remember, because they are forming supplementary. If I solve this mess, I will get 180 degrees minus 71 degrees. And that should be 109. Yeah, 109 degrees. So this is how you will solve these type of problems. And if you get these type of questions in any kind of assessment or any competitive exam, just remember the opposite angles, they will be supplementary if and only if the quadrilateral is inscribed in the circle. So always check whether the quadrilateral is touching the circle or not. All the vertex, they are touching the circle. I hope it makes sense.